In this video, we'll take a look at further web application security, specifically at SQL injection, one of the most dangerous attack forms that you can experience when developing web applications. SQL injection is an injection attack, and injection attacks work by injecting untrusted code into an environment via some form of an input channel. So basically, any time that your application accepts input from wherever, whether it is direct or indirect input from an end user, or input that comes to you from a database or through a web connection or through a file, it really doesn't matter. And if an adversary has some opportunity to introduce code into that channel, and that code eventually gets executed somewhere along the execution chain, you have a risk of an attacker being able to execute arbitrary code. And that, of course, is not a desired situation. We saw last week how cross-site scripting works, where an attacker is able to inject HTML and JavaScript into a web page, which then affects how that web page is rendered in a browser. That is a form of an injection attack. And as a result, it is something that we'll have to think about when we design and build our applications. Cross-site scripting, by and large, does require a vulnerability in a web server, but the web server is generally, again, not the subject or the victim of the attack. The victim is the person who renders the page that is generated based on the information that you provided. In a SQL injection attack, that is different. In a SQL injection attack, you're not targeting someone else's browser. You are targeting the database management system that functions as a back-end to your web application. And of course, that's a bit of an issue because a database management system typically gives you access to data, and data is, by and large, what we try to defend. So let's say that we consider an application, and that application takes user input, maybe just a web form that a user is presented. In this case, it's a web form that asks the user to input a username and a password. This part here is what is presented to the user as the prompt for what you expect them to type, the username and the password. And then over here, we provide a placeholder for the input box. This is where the actual data collection will take place. The input box will be known as a user input and the other one as a PW input. HTML doesn't care about these names, but the back-end application can use it to retrieve whatever value is located at input field user and input field PW. These inputs have different types. Text means that you can type whatever you want in there. It's an open-ended text input box, one-liner though. And the second one, password, is also a one-liner input box, but is one that masks out what you type with bubbles or stars or whatever you would like it to be. And then the third input happens here. It's a submit type, so that is the button that says submit this form. We can also give it a value that is just, in this case, the text that is displayed on the face of the button that shows up there. But that means that in this case, the user has two input fields that he can type in, text and password, and one button that they can click, submit. Once they hit that submit button, this overall form is submitted. Where? Well, to the file login.php that lives on the server where this page originally came from. And it's going to be posted. There's two methods that you can send data to a web application, post and get. Post seems to be more common at this point. The file is called login.php. From an attacker's perspective, already somewhat interesting, because now we know that there is a page that we didn't see yet before, just by looking at the file name. We also know that it is a PHP file. PHP is a web scripting language. It has been around for a very long time. So, lots of information here in one web page, but this is what we were just talking about. Remember, when a user can inject information that is passed to an application, there is a potential for an injection attack. And here we have two fields. that they can easily inject data in, with a little bit more effort maybe here, although that would most likely be somewhat useless since this value will most likely not be retrieved in the application, but it is there. Now remember what happens when we do this. When we submit our, let's see my mouse, okay. When we submit our web, so from left to right, we have the adversary who has a browser under their control. That's the box with the arrow in it. The browser sends an HTTP request to the web server. That, the first time, is most likely just a URL, and when the URL is received by the web application, it sends back some form of a page content, some HTML and maybe some additional elements like an image or a video or some JavaScript or cascading style sheets. It doesn't really matter. It is a request and there's a response. In the response, the browser might also set a cookie, and that means that all subsequent requests that originate from the browser to that same website will also have that cookie together with the URL and maybe the form data that the user just input. For example, the first request receives a response with this HTML. The second request posts these data fields, these 3 data fields, to the web application in addition to the URL. And maybe if there was a cookie, the value of that cookie as well. The web server doesn't really do a whole lot with it. The web server recognizes this as a PHP script, and therefore it immediately, once it verifies that the request response were valid, passes it over to the PHP processor, the application server, and that is the program that is going to inspect what the web server just handed it. And it may start looking for field names, it may start doing other things. It's going to use what the adversary sent in the browser to the web server to create a new SQL query. In other words, the user, through their input, is going to affect what the SQL query on the right here looks like. And the SQL query is executed against the database. But if that is the case, and if we are not careful, we now have a channel by which an adversary can influence SQL queries that are executed against the database. And that might mean that the adversary has the potential to make changes to that data, and to have a query executed wasn't necessarily the query that the developers intended. Those results are being passed back to the application server, who processes them and then most likely uses some or all of the results to create an HTTP response being sent back to the adversary. So it's fairly easy to envision a situation in which an adversary could craft some input that, instead of looking for, let's say, your account details, will return the account details of someone else, or maybe of all users on a system. And by doing that, by having such a SQL injection vulnerability, an attacker can potentially access, retrieve, update, delete, drop whatever is stored in that database. And that is, of course, not a situation that we want to be in. When the application server receives that data, this is a sample script in PHP. Now, first of all, I have insecure code here. I marked it. This is insecure. Don't ever do it this way in your own programs. But what we're doing, so line by line, the first line, if you haven't seen PHP, it's a little different than probably what you have used to. A $sign just means it's a variable. So the variable called user is assigned the contents of the variable _post user. That is a dictionary or a mapping or an associative array, however you want to call it. Basically, it extracts that user input field from the post variable. And remember, if we go back here, the user input field will then contain the text that the attacker, the adversary, input there. We do the same thing for the PW field. So at this point, the application has 2 variables at its disposal, user and PW, and those variables hold the content that the user entered into their browser. We're going to use that to create a query. Select role from users where username equals quote PW quote and password equals quote PW quote. That should probably have been $user and $pw, but it doesn't really make a whole lot of difference. But what is important to realize now is that here we are embedding information that the adversary sent us into our query, and that is being executed against the database. This is pseudocode. This won't work exactly the same way in PHP, but it's close enough. Now, if that query doesn't result into anything, then in that case, the user's username and password are not accepted, and otherwise they are accepted. So this is an authentication script here. Basically say, hey, if I have users that have a given username and password set, then I'm going to let you in. If nothing matches, I'm not going to let you in. Under normal circumstances, I could enter username admin and password admin. SQL now becomes select, once those variables are replaced with their actual values, select role from users where username equals quote admin quote and password equals quote admin quote. That looks reasonable, other than, of course, there appear to be credentials stored in plain text in this database. But the query by itself is not unreasonable. But what happens if the attacker would insert the value quote or 1 = 1 semicolon dash dash? Remember, dash dash in SQL is a comment symbol, which means anything following dash dash will be ignored by the SQL processor, and semicolon is a symbol that is often used to terminate a query. So our string now becomes select role from users where username equals quote quote. Well, are there any users that have no username? No, probably not. Or are there any usernames for which the value of 1 is equal to the value of 1? Semicolon to end the query, and dash dash to make the query processor forget everything that follows. So in our case, in other words, in this case, there is no check for the password anymore. The password is now considered to be a comment. And what does this return? Well, of course, this returns all roles. There is no username that is empty, but all users have a value of 1 that equals the value of 1. And if I go back to this, if role equals blank, no, role isn't blank anymore. It holds a whole lot of values. Well, in that case, accepted equals true. We don't want that. You don't want to take user input here and inject it directly into your string. You want to take some care of cleaning that up, or maybe even better, signaling to the query processor which parts of the query it can trust and which parts of the query it cannot trust. How we actually do that, how we can use SQL injection, we'll look at in further videos. But for now, just this simple one string, quote or 1 = 1 semicolon dash dash, could potentially give us a SQL injection authentication bypass, where we could skip the username and password field if it hasn't been implemented correctly.